So 7.2 is the start of the trig definitions. It's trigonometric functions, trigonometric functions of angles. Okay? Now, first, we start with a unit circle. Centered at the origin. So we're going to draw a circle centered at the origin. Unit circle means that the radius is 1. Do you guys remember the equation for a circle centered at the origin?
Not quite. Isn't it the K and the A?
It does, but if there's no shift, then it's just going to be x squared plus y squared. Yes, x squared plus y squared is going to be the radius squared. Okay? So we're starting with the unit circle. So let's label these points. This is 1, 0. This is 0, 1. Negative 1, 0. And 0, negative 1. Okay, so now here's where all these trig definitions are going to come from, all right? Let's draw a triangle. A right triangle sitting in the first quadrant. So basically this segment extends all the way to the circle. We're going to call the coordinates of this point x, y because we don't know what they are. Kevin, you all right? You're like shaking back there. Maybe you should not wear shorts to school.
I have pants.
Okay. Now, in addition, we're going to label, kind of like what we talked about yesterday, we're going to pretend that we rotated an angle to get to this side. Remember how what did we call this? Initial side here? And this was terminal, I believe.
Mr. G?
Yep.
Every time you said theta yesterday, I kept thinking you were writing beta inside the circle, so on every one of my pictures I wrote beta.
Well, just make the switch. You should be all right.
Beta inside the circle?
No, I wrote beta inside the circle.
Okay. Now, let's do some things here. Cosine theta. Remember your SOHCAHTOA stuff from geometry? Okay. Cosine adjacent over hypotenuse. Okay, now, so if we're looking for cosine of this angle, the adjacent side, you guys see it's the bottom part, right? That matches up with whatever x is. We don't know what x is, but we'll label it x. What's this part of the triangle going to be labeled?
Y.
And what about this one?
X, Y? H. Oh.
We know what this
X
is.
squared plus y squared.
What's the radius of this circle? 1.
R.
How are you finding it?
It's a unit circle. The radius was 1 to start with. Okay? So, cosine we said was adjacent, which is x, over hypotenuse, which is 1. Do I have to divide by 1? Nope. So, here's one of the 6 definitions that you need to know. Cosine theta will always correspond to the x-coordinate on the unit circle. Okay? Sine theta. Remember, sine is what over what? Opposite, which is y, over hypotenuse, which is 1. So y over 1 is just y. Tangent theta.
Adjacent over.
Opposite over adjacent. So y over x. These are the ones that you remember, right, from SOHCAHTOA? All right. There are three more that you really haven't talked about. These are called the reciprocal trig functions. Secant, cosecant, and cotangent.
CSC.
Okay. Secant, cosecant, cotangent. I wrote them in the order that's going to correspond to this order up here, okay? Bless you. Secant is the reciprocal of cosine. So we're going to say it's 1 over x. Okay? This is just a definition. Cosecant is the reciprocal of sine. So the reciprocal of y is 1 over y. This is the one that does make sense. Cotangent and tangent are reciprocals. So that's going to be x over y. Okay? Initially, what I've seen in the past is some students think that cosine and cosecant are the ones that are reciprocals. Okay? It's not. It's the other way around. So just remember that it's backwards in the letters that start with the name. Does that make sense? So cosine and sine and cosecant would be reciprocals. All right, so these are the 6 basic trig definitions. Are there any questions on the green ones? These are just ones you're going to have to learn. Okay, so now here's how we use these. Evaluate all trig functions for, let's say, theta equals pi over 2. Okay? So the first thing we're going to do when they give us an angle, remember how yesterday we kind of drew an angle on the xy plane? Pi over 2, do you guys know what that is yet? 90 degrees. So what we're going to do is draw an angle that starts here and ends right here and makes a 90-degree angle. Okay? Now here's the question. We're always going to think about the unit circle. So think about plopping a unit circle on this little grid. What would the coordinates be for this point up here? 0 and 1. This is all you need to evaluate these functions, you guys. As long as you know the point on the unit circle, you can find all of these all day. Okay? So let's all day.
All day, every day.
Cosine theta corresponds to what?
0.
The x-coordinate, which is 0. Sine theta means look at what? The y-coordinate, which is 1. Tangent means do the y over the x. 1 over 0 is undefined. Very good. So not all of these will work necessarily. Okay, especially on the axes. Okay, if we're anywhere in between, like in quadrants 1, 2, 3, 4, you'll have values for all 6. All right. Kevin Levitas, why don't you take us through the last 3? What are those going to be? Secant.
Oh, secant. Okay.
Which is good.
And then cosecant.
Yep.
Is, I guess 1 over 1, so it's 1.
Good.
And then cotangent would be 0. 0 over 1.
Good. Are there any questions on how we drew the angle and how we got these 6 values? Yes.
Why isn't it a triangle?
It can be.
That was just confusing.
Yeah. You can always draw a triangle in there. The point is, once you know these definitions, you're not going to need those triangles. Okay?
How you know that the points are 0 and 1?
Because it's x is 0 on the y-axis, and the radius of the unit circle is 1.
No, how do you know that the x is 1?
That the x...
It's always going to be 0.
Always, yes. Up here it's 0, 1. Here it's 1, 0. Here it's negative 1, 0. And here it's 0, negative 1.
They can't say like 5 and 4 or something.
Well, it could, but you're going to reduce it so that it's on the unit circle. We're always going to be on the unit circle when we do this. Yes?
So the unit circle will always be like those coordinates?
Yes.
You can't like move it or anything?
Yes.
You won't do like anything weird?
Yes. I mean, there will be something else where I give you, here's this point that's not on the unit circle.
But
Find the
circle
cosine,
will
but you
be
can
based
still...
off, like 0 and then,
Yeah.
like, next, yeah.
You can still reduce it. We will. Okay. Are we good?
I think so.
All right. One more example.
That's it?
Well, before we do a harder one.
Okay.
Let's say theta equals negative 9 pi.
Oh, wait. I have questions.
Yeah.
Oh, wait, no, just kidding.
Okay. You guys know what pi is, right? 180?
It's tasty.
Negative means we just go the opposite direction. Okay? So if I start out going this way, from here to here is negative 1 pi. Does that make sense? If I go all the way around, that's negative 2 pi. 3, 4, 5, 6, 7, 8, 9. Do you see how I got there so quick?
Uh-huh.
So here's where we end. We're going to spin around a whole bunch of times, but the point is we land on the point that has coordinates negative 1, 0. Okay, once again, if you're not sure how we got there, we're spinning, rotating in the negative direction. This is 1 pi. 2 pi completes the whole circle, right? 3, 4, 5, 6, 7, 8, 9. You don't have to draw all those revolutions in. You just need to know where you finish. That's the most important thing.
What?
It's not about the journey. It's
I
about
was
the
like-
destination. Why it starts from the right?
It always starts here. By definition, we always start here. All right, so cosine theta.
Quickly, each pi is half what? Half.
Everybody, what's cosine going to be? Negative 1. Good. Sine theta. Good. Tangent is y over x. So
It's 0.
0. Do you guys see how we're getting those so quick now?
Yes.
Secant is the reciprocal of the cosine value.
It's negative 1.
It's still negative 1, right? Cosecant is the reciprocal of 0, which is undefined. Cotangent is either x over y or reciprocal of tangent, which is still
0.
undefined, actually, because it's 1 over 0.
Oh.
Okay? Any questions on how we got these 6?
We're going to have to do this a lot.
Oh my gosh, yeah.
Oh.
Okay.
I'm still confused on why the point's negative 1, 0.
Because we're on the unit circle.
Yes.
Where does the unit circle
So-
come from?
Okay, here's where it comes from. You know how that hypotenuse, when we did the SOHCAHTOA stuff at the beginning, was 1? We wanted it to be 1 so that these values were easy to calculate. So instead of focusing on a large circle that has a radius of 7,
So it could technically be any circle.
yes,
But we just chose
we
this one to
shrunk
make
it down.
easy.
Yes, exactly.
Okay. Okay.
Circles are convenient.
Unit circles are very convenient.
Okay.
Because otherwise you'd have to say, well, let's draw the circle, let's find the hypotenuse. We're not doing all that. We're just saying, look at the x, y coordinate, we're done.
Okay, so I know, so whenever you have the circle with the lines, the pokey ball looking thing, and it's negative 9, okay, yeah, no, I lost it. Like, I know the 9 revolution things, but, like, where'd you start?
Always start here on the positive x-axis.
Okay, so you always, okay.
And then we rotate. Positive would be to rotate counterclockwise. Negative means you rotate down.
Okay.
So we're going to go this way is 1 pi, 2, 3. We just keep going and it eventually we end
You're
there.
just saying so casually, you're like,
You just have to think of the quadrant.
Think of the quadrants.
Quadrants, but if it's positive. 1, 2, 3, 4.
Oh, I see what you're saying.
Yeah.
1, 2, 3, 4.
Yeah.
Rotating positive means to go through the quadrants in that order. A negative angle goes backwards. 4, 3, 2, 1. Clever. I didn't even think of it that way.
Nice.
Okay, everybody good?
I didn't get it in. I didn't explain it.
All right. So here's an example. Let's say we have a point.
You've got 10 minutes.
Oh, good.
Okay.
Point has coordinates. Let's say 7 and negative 4 root 2.
That's painful.
And we want to find cosine theta, sine theta, tangent theta. Okay, so first we're going to draw a picture. And there's like 3 or 4 different ways to do this. I'm going to do this the way I think is going to help us for the rest of the trig stuff that we do. Okay?
So all you.
Yes. What quadrant is 7, negative 4 root 2 in?
4.
So down here somewhere, right?
Yeah.
So that means that in order to get here, here's this angle theta, this really large angle theta, and the coordinates of this point are 7, negative 4 root 2. Okay?
Why is that supposed to be the unit circle?
Well, that's what we're getting at. Is this on the unit circle?
No.
There's no way,
Oh no.
right? I mean, this is 7 units. That's way too big, right? So here's the issue. Not on unit circle. Okay? So let's find the radius. Find radius. So we know x squared plus y squared equals r squared, right? Everybody with me on that? Instead of x squared plus y squared is 1. We don't know what the radius for the circle is, so we're going to set it up so if we can find it.
Isn't that right?
So yeah, let's just plug in. X squared will be 49. Y squared, 16 times 2 is 32. 49 plus 32 is 81. So take the square root.
So radius is 9.
So what we have, you guys, is a circle. Wow, that's not a good circle.
That's okay. We know what you mean.
We have a circle that has a radius of 9, right? Now, to keep things consistent, hold on, it's not a big deal. To keep things consistent, we want to always be on a unit circle, okay? So you know what we can do? Divide everything by 9.
What?
Knew it.
Divide everything by 9 so that this point becomes what?
7, 9.
7 ninths and negative 4 root 2
Over 9.
over 9. And if you don't believe me that this is going to have a radius of 1 now, you can plug it back in and say, well, we're going to get 49 over 9 plus 49 over 81. 32 over 81. 81 over 81 is 1. Everything works out great now. Okay? Do you guys see how we're getting this point? Okay, so now look. Easy. Cosine theta tells us to look at what coordinate? So what's cosine? Piece of cake. Sine theta is?
Oh, it's negative 4 over 2 over 2.
Over 9. And then tangent means to do y over x.
So
It's negative 28.
It'll be negative 4 root 2 over 7. The 9s, if you don't believe me, they're going to go away because you do negative 4 root 2 over 9 over 7 over 9. Dividing by 7 ninths is the same as multiplying by 9 sevens. Cancel, cancel. Now you don't have to do that ever again. What's going on? You guys seem... What's up?
we have 7 minutes.
Why what?
The radius is 9. I got it.
You gotta divide by 21.
Look, Kevin, we could have done it a different way. Let me outline it for you. Okay? Draw a triangle. Radius is 9. Here's theta. Here's x. Here's y. Do the same definitions. Cosine is adjacent over hypotenuse. Okay? I don't like to do it that way because we're always going to be talking about unit circles. So even though this took an extra step to get there, it's going to help you guys conceptually later on.
So then, let's say radius was
But if we
7.
Then you would just take the x coordinates and the y coordinates divided by 7.
see a problem like that. It's not unit circles.
So all you have to remember, if it's not a unit circle, find the radius of the circle and then do what?
Divide it by
Just divide your coordinates by the radius, and then you can use your definitions.
It's not just a special thing for this.
No, always.
It's out of the circle, that inner circle, we have to do divide by.
Yes. Now, can I borrow someone's packet real quick?
Sure.
Thank you. If you go to the front page,
Oh, is this? Oh. Can we turn it in? Are we gonna have
just odds. Unless I say go back and do the evens, just odds. Okay, guys, look. Listen carefully. We're almost done. Some of you have already done this. This, you see the bold circle?
Yeah.
You see that the radius is exactly 1?
Right.
This is a unit circle. Right now, all I need you to do for the last part of your notes, this angle over here, do you mind if I do this on yours, Abby?
You can do it on mine.
This angle is 0 degrees, which also happens to be 0 radians, right?
Oh, the little tiny.
What are the coordinates over here? 1, 0. We're going to fill in some more later on. Tomorrow we'll fill in the ones in between. But for tonight, all you have to know is 0. Right here is how many degrees if I go from here to here?
90.
90 degrees. How many radians is this?
Pi over 2.
And what are the coordinates up here?
0,
1. Oh, said it backwards. 0, 1. Sorry, Abby. And then now you can fill in the rest.
Cool.
You're like, oh, my packet. Sorry.
That's it.
That's it.